Have you ever gone to the dentist and wondered, how does that thing they put in my mouth work? Well, I haven't myself, but nevertheless, I will show you how that silly thing works. An X-ray is a regular electromagnetic wave. In the center is visible light. Over here, we have infrared and microwaves, while on the other side we have ultraviolet and X-rays. Because of their tiny wavelength, these waves can easily penetrate many different materials, such as wood, plastic, some metals, and skin. It works by blasting a metal surface with electrons. 99% of the electrons are absorbed as heat, and the remaining 1% are reflected as X-rays. Alright, enough of this theory nonsense, time to see some cool stuff. So I bought a tube from this sketchy website, which also sells other cool stuff like uranium, and all chemicals you might ever need. I also found a Geiger counter on eBay. Operating the tube is pretty simple. All you need to do is connect a 30 kilovolt power supply to it. I built one with stuff I had lying around, and the first tests were semi-successful. We can see the Geiger counter is measuring 0.015 milliröntgen per hour. If we look at this card here that came with the Geiger counter, we can see that we are not exceeding background radiation. Strange, something's not right. Wait, let me plug this in real quick. Hey, look at that, we have 8 milliröntgens per hour. Let's check our card again. Oh. It exceeds the alert authorities mark by 8 times. Not bad. In fact, after making some changes to my power supply, like dipping it in oil, that's gonna be fun to clean. We measure 1,300 milliröntgen per hour, which is 160 times more than what I was getting before. But what are we measuring? If we look back to chemistry last year, yes, I know we all hated it, we can remember that there are 3 types of radiation: alpha particles, beta particles, and gamma rays. Alpha particles are helium nuclei, beta particles are just electrons, and gamma rays are not actually particles, they are electromagnetic waves. This Geiger counter can measure all 3, and in this case it is gamma rays. The good thing about these is that, like light bulb, they leave no trace. The moment I turn the power supply off, all of the radiation disappears. Now, what can we do with this besides reading numbers on a screen? Well, first off, if I put a camera directly under the tube, you can see how much noise shows up. This is because the camera sensor gets bombarded by the rays, which excite it. Now, let's take some cool photos. I bought this special intensifying screen, which is a fancy piece of paper that converts X-rays to visible light. Using a DSLR camera, I can, in theory, take a long exposure photograph of an object. But what object? As a first test, I tried placing a key between 2 pieces of cardboard. If it worked, the key would be visible. However, I spent hours upon hours trying to get an image. It seemed that I had tried everything, to no avail. But one day, I had the genius idea of flipping the sheet around. Aha, now that's a key. Looks like I had figured it out. I then proceeded to find things around the house to take pictures of. Here's an audio transmitter. Here's a small Bluetooth speaker. Here's a Rubik's Cube. And finally, here's a fish. Now, I would love to take some more cool photos, but unfortunately, this project is due in 2 hours, and I still have to edit it, so that's it for now.